Now we're talking with Stephen Ezell. He's the Director of Global Innovation Policy at the Information Technology and Innovation Foundation. How are you, Stephen?
I'm very well. How are you this morning?
Great, thank you. So we're talking about a new document that you prepared about talking how the transportation network is going to change with new technology, right? It's called From Concrete to Chips, Bringing the Surface of Transportation Reauthorization Act into the Digital Age. I mean, very, very trendy topic nowadays, right?
Absolutely. As Congress reconsiders reauthorization of the Surface Transportation Act, it's a timely moment to have a discussion about the types of investments in the U.S. transportation system that provide the most bang for the buck.
So nowadays there's a lot of talk about autonomous driving, and I guess this is where these two meet, right? I mean, a lot of people are talking about how technology in the automotive industry is much more advanced than legislation and infrastructure. And so big part of that autonomous driving idea is that the network of roads and streets has to be really able to communicate with vehicles, right?
You know, that's a very large and interesting part of the discussion. There are really two dynamics to the debate and the technology. So the U.S. Department of Transportation has had a program called the Cooperative Vehicle Research Program, formerly called IntelliDrive, that it's worked for the past 15 years. And the goal of that program has been to be able to connect vehicles with the ability to communicate with one another and with infrastructure such as traffic signal lights.
Yeah.
So that at an intersection, they would be able to communicate to avoid accidents or collisions. Now, what has evolved in the technology space, in the automotive sector in recent years, is the advent of these driverless, these truly autonomous vehicles like the Google car. And in theory, these vehicles are self-aware of the roadway around them.
Yeah.
So they wouldn't necessarily have to be able to communicate with a traffic light, for example, because they could stop themselves and detect pedestrians at an intersection. But the reason, despite the tremendous attractive capabilities of an autonomous car, that you would still want to be able to communicate with public assets, such as roadway infrastructure like traffic lights, you wouldn't want to be in a smart driverless car that's still stuck at a traffic light when there's no other cars around you because it can't communicate with it.
Yeah.
So we are going to need to have a thoughtful system that ensures that even vehicles that can drive themselves still have the capacity to communicate with other vehicles and with infrastructure.
Yeah, and it's very interesting because, I mean, I think the traffic situation around the country is getting to a point which is almost unlivable and impractical. So I gave you an example. Sunday, I landed at Newark Airport in New York, and it took 2 hours to get to Manhattan, to Soho, 2.5 hours, just because to get into the Holland Tunnel, I mean, there was like a huge bottleneck. I mean, and something has to be done, right? I mean, so that cannot be sustainable for too longer after now.
Well, last year congestion cost the U.S. economy $168 billion.
Wow.
And it's estimated that if we do not abate traffic congestion, that from 2015 to 2030, it will cost the U.S. economy in aggregate $2.8 trillion. And the average congestion penalty paid in lost time and productivity by the average American will rise to $3,000 per person.
So do you think there's time between 2015 and 2030? Because, I mean, I've been in this drive from New York Airport to New York, I was seeing the reconstruction or reinforcement of old bridges that are collapsing pretty much. And like, it seems that it will never be done with that kind of traffic and those kind of problems they have there. I mean, is there really time in 15 years to get to a point that is something that will be much better than now?
Well, I think there is time, but what there is a serious lack of is political commitment and political capital to make the investments necessary. You may be aware of the recent study by the American Society of Civil Engineers, which said that there is a $2.7 trillion infrastructure investment deficit in the United States. And so if we're not repairing the faltering bridges, and if we're not repairing them with new technologies like embedded sensors that can monitor the stress on the roadways or the icy conditions of the traffic, we need to be sure that we're not just putting in place, new asphalt. We're using flexible forms of concrete, better materials that have more durability and reduce long-term maintenance cost. So we need to be using the most advanced technologies, ideally technologies that are even roadway materials that are self-aware and able to communicate their status to transportation managers. So we should know instantly when there's a pothole that needs to be fixed.
Yeah. So, I mean, it seems to me, and you're the expert, I'm just the observer, that the whole situation is like the actual bottleneck, the whole tunnel, because there's a lot of information coming into the thing. There's a lot of problems like politics, economic problems, budgets, new technologies coming into a point where you have to like funnel all of them together. And that's a very, very challenging proposition, no?
Right. Well, over the last 20 years, the number of miles of roadway in the United States has increased by 4%, while the traffic that rides over them has increased by about 40%.
Wow.
So we're not going to be able to deal with this challenge by building more roads. We are going to have to use the existing infrastructure and assets we have in a much more efficient and productive manner. And so to deal with challenges like the one you're having in Holland Tunnel and elsewhere around the country, we have to do a couple things. One, it's estimated that about 25% of congestion on major roadways is a result of traffic accidents, right? So if we can eliminate those accidents, that will help tremendously. Another thing we can do is just even using these computerized adaptive traffic signal lights that are aware of what's happening on the roadway. Tucson, Arizona recently did a citywide installation of smart traffic lights. They cut their congestion down by 40%. So if we can do these two things, eliminate accidents and have better technologies to manage traffic flow, that will help the congestion problem significantly.
Yeah.
And by the way, the data is starting to come in about vehicles that have driver assistance technologies like lane departure warnings or blind spot detection or collision avoidance indicators. And data from Volvo and Toyota shows that cars with these pre-collision indicators are in 30% less accidents.
Yeah, absolutely. I just drove a new Volvo. I'm sorry for interruption, but I just drove a new Volvo, and they promise, which is really, exciting, I guess, to hear, that by 2020, nobody should die or have serious injuries in a Volvo car, which is kind of amazing. So that's incredible, top to what you were saying.
Well, that's a good point. So both Sweden and Japan have articulated this vision of a zero traffic fatality society. They want to fully eliminate all traffic accident deaths in their countries by 2020. And I think that's the kind of aspiration we should aspire to in the United States. We lost 33,000 citizens last year due to traffic fatalities. And we policymakers need to focus on the deployment of these types of technologies and solutions to eliminate fatalities.
Yeah, so that's one of the equations I get, or the parts of the equation, traffic, congestions, and all that. The other one is technology and energy. There was a video a few months ago running out on the internet about this plan that to install solar panels over roads to create energy and make intelligent roads. That, I don't know how serious was it. I think it's a couple of entrepreneurs from somewhere in the West Coast. That's not possible because that should be like so expensive, right?
I wasn't aware of that innovation, but there's a tremendous opportunity if somebody could figure out how to, embed microscopic, solar photovoltaic cells into concrete. I mean, these are massive heat generating sources.
Yeah.
If there were ways to trap the heat potential that exists there and turn it into energy and seamlessly connect it, into the electrical grid, that would be a potential breakthrough innovation, I think. Just on this point about energy and environmental benefits, the organization, the Intelligent Transportation Society of America, just released a study saying that if we deployed these intelligent transportation systems extensively nationwide, America could save 650 million barrels of oil and 120 million metric tons of carbon dioxide emissions over the next 10 years.
Yeah, that sounds encouraging. And actually, the trucking industry, I think, is already trying to figure out something. Freightliner, the division of Mercedes-Benz, this month unveiled an 18-wheeler that can be autonomous driven. So, I mean, that's like one aspect of the transportation system that could be really benefit from these kind of technologies, right?
Absolutely. And as you say, with these autonomous trucks, what they can do is platoon and drive very close together. So it's been estimated that trucks moving down a highway in a platoon could get 2 to 3 times as much use out of existing roadway, and they would cut their fuel consumption by 10%. And a recent study done of the U.S. trucking industry found that it could save $24 billion a year through those types of autonomous driving and platooning technologies.
Yeah, fascinating topic. We're talking to Stephen Ezell. He is the Director of Global Innovation Policy at the Information Technology and Innovation Foundation. So is there a way, I mean, unfortunately we're running out of time here. We have like less than a minute. Is there somewhere that the audience can look more in detail to the study and like learn more about your work?
Yes, we are online at itif.org. And you can find our most recent paper, From Concrete to Ships, Bringing the Surface Transportation Reauthorization Act into the Digital Age, online at itif.org.
Well, thank you very much for your time and sharing your information. Very, very interesting again. And I hope that you and me will get to see some of these advancements and like get rid of that awful traffic in New York.
I agree. I look forward to that in the future. Thank you for having me on.
Thank you. Have a great day.
Este programa fue una producción de National Latino Broadcasting.